Welcome to this lecture on solar PV accessories and schematics. Solar PV systems can be installed offline and online, that is, PV systems can be connected to the grid mains or they can be installed where grid is completely absent. Where there is no connection to grid electricity, solar PV systems can be used with both DC output or an AC output. It should be noted that contrary to the popular belief, a lot of appliances are available that run on 12-volt DC current. Most electronic devices in fact are DC based. Televisions can be bought with DC input and so can be fans, refrigeration devices, lighting and even heating devices. In fact, using DC output of the panels in the DC appliances eliminates the need of an inverter. An inverter is a device that converts DC electricity to AC. There are two advantages of using an inverter. First, it allows the solar PV system to be used within an existing AC infrastructure, wiring and appliances. Secondly, it also allows PV output to be used in conjunction with the electricity mains. If a system with AC output has to be designed, then there is an advantage if microinverters are used. Solar microinverters are small inverters that are connected to each individual panel as opposed to large inverters that deal with the output of all the panels. The advantage is that if a single panel becomes shaded, then the output of the whole string of panels isn't affected. This is because each microinverter feeds into the grid independently. This would not be the case if one central inverter was being used. The disadvantage of microinverter is that the cost of electricity per watt increases. It has been reported that central inverters cost approximately 40 cents per watt, whereas microinverter costs approximately 52 cents per watt. Similarly, a system can also be designed with a bypass diode instead of microinverters if shading is a concern. A bypass diode is a cheaper but a less efficient solution for the shading problem. Please note that it is not always possible to place panels on the field. Obstacles are always around that can include buildings, trees, electricity or communication poles, etc. Now let's have a look at the storage options. PV panels with storage options provide several advantages. Number one, it allows the possibility of energy generated through the day to be used through the night. Secondly, it provides an energy buffer. Battery provides an energy buffer. Any drop in PV output because of cloud cover or any other factor can be made up by the battery energy bank. And number three, even for a grid-connected system, the batteries can provide backup power in case of power failure in the grid. Now, it should be noted that if PV installation is being done to make use of feed-in tariffs, then it must be checked beforehand with the utilities or the electricity supplier that if they allow systems with battery storage or not. In many countries, low-cost UPS systems are available and are made by the local cottage industry. These UPS systems can be integrated directly with solar PV systems to provide storage options. The UPS systems also include in them an inverter and a charge controller in addition to the battery. In developing countries like Pakistan, India, Sri Lanka, very cheap UPS systems that use lead acid batteries are available. Modern battery systems with lithium-ion batteries are also available in the market, including Tesla's Powerwall. For a whole list of lithium-ion battery banks, a URL to an article is included in the resources section. It is important to choose the right gauge of wire for any given system. The greater the amperage of the design system, the thicker the wire is required. The cost also goes up with wire thickness. Some of the charts are available on the internet that will help you select the right wire size. A link to the URL has been included in the resources section, and that will tell you about how much ampere would mean what gauge wire to select. The wiring of a DC and AC system has also been included, and you will note that in a DC system the inverter is missing, and see the resources section for more details. There's another important element called the charge controller, as can be seen in the circuit diagram. A charge controller is important to battery health. It should be noted that battery life can be reduced if it's overcharged or when it's utilized if the charge is low. So if the battery is overcharged or undercharged, it loses life. And a charge controller is there to protect the battery from exactly that. The battery shouldn't be drained completely. If it is drained fully, then the number of charge cycles the battery can be used for gets reduced. A charge controller, gives you control on protecting the battery. One can set a voltage at which the output from the battery can be switched off based on a particular battery voltage. In the industry, the term DOD or depth of charge is commonly used. Battery bank therefore should be designed above the capacity for which the battery backup is required. For instance, if for a fixed power output 2 hours of battery backup is needed, then the battery bank should be ideally have 3-hour capacity for the same power. Standard charge controllers are available in the market, and they're very low price component, but one can also make a customized charge controller, and one can do it themselves. Circuit diagrams are available all over the internet. And with this, the lecture on PV schematics and accessories is concluded. Thank you for your attention.